All right, my calculus kids, we are ready for the best lesson in calculus ever. This is the lesson on the power rule. And so I want to kind of build to what they're talking about with this lovely power rule. So in the past, up to now, if I asked you to find the derivative, we've seen how to do it by hand, we've seen how to do it with the calculator, but if I want to look at by hand, using limits, here's what we would do. We would take the limit as h approaches 0 of the formula is f of x plus h minus f of x all over h. And remember, this was a three-step process the way that we looked at it. We first figured out what f of x plus h is, and then we worked on f of x. Well, we know what f of x is. F of x is just x squared. And then we put the whole thing together as the limit. So let's see what it would look like. If I do x plus h in here, it's going to be x plus h quantity squared. And we know, if we FOIL that out, it's x squared. I get an xh, I get another xh, so I have two of them. And then I have an h squared. So here's my f of x plus h piece. Here's my f of x piece, and I'm going to take that and put it into this limit formula. So the limit as h approaches 0 of f of x plus h, we said that that is x squared plus 2xh plus h squared minus f of x, well, f of x is x squared, all over h. And if I've done it right, then it should be that things should cancel out. So I do. I've got an x squared on one end and an x squared on the other. So I can also see that everybody is divisible by an h. The pieces I'm left with, when I divide by h, I can simplify it even more. So now I'm at the limit as h approaches 0 of, if I divide out the h, I've got 2x. If I divide out the h here, I have a plus h. And now I'm ready to take the limit. So I plug a 0 in for the h, and I end up with a derivative that is 2x. And you say, yeah, that's really cool. That's what we've been doing all along. But wait, there's a shortcut. It's called the power rule. It's the most wonderful thing ever. If my function is y equals x squared, here's what the power rule says. To find the derivative, take the power, bring it down in front, and take the variable to one less power. 2 minus 1 is 1. 2x, look at that. I did that in no math steps. I can just automatically figure out what derivatives are by the power rule. Again, the power comes down in front, and the variable goes to one less power. So how about something like this? What if I wanted you to find the derivative of x to the fifth? Now think about that back in this problem that we just did using limits. If I were to use the limit definition, if I had to find x plus h to the fifth power, that would be a hot mess. That would be a ginormous amount of work to be able to do it. Could we do it? Sure, you could do it. But it's going to be a whole lot of work to get there. So in this case, if I have x to the fifth and I want to find the derivative applying the power rule, here's what it says. Bring the power down in front. Bring the variable to one less power, done. All of your work would have led to that answer. So, is that not amazing? It's the best thing ever. All right, so here's the notes for the section 2.5, the power rule. I kind of gave you the intro on this whole thing. If you're x squared, you're 2x. If you're, and we just did all the work for that. If you're x cubed, you're 3x squared. If you're x to the fourth, you're 4x cubed. If you're x to the fifth, you're 5x to the fourth. Woohoo, it's the power rule. It says bring the power down in front and times it by the variable to one less power. So real quick from his examples, x to the 37th, 37x to the 36th. You can use the dy over dx notation, you can use the y prime notation, it doesn't matter which one. X to the 9th, 9x to the 8th. Remember that y prime is the slope of the tangent line because that's going to come up. They're going to be asking us to find equations of tangent lines in this section in a few minutes. So remember that when you're finding the derivative, it's the same thing as finding the slope of the tangent line. Sometimes in order to use the power rule, which is so wonderful, you have to manipulate the function first to set it up so it is a power, so you can apply the power rule. So in other words, 1 over x is the same thing as x to the negative 1. When you take the derivative, negative 1x to the negative 2, Mr. AP says, don't leave me negative exponents. Put them where they go. Well, negative exponents go in the denominator. They change locations. This one is an x to the negative 4th. All right, apply the power rule, negative 4x to the negative 5th. That leaves you with a negative 4 over x to the 5th. Again, a negative exponent puts it in the denominator. The square root. Well, the square root is like raising it to the 1/2 power. Bring the power down in front, bring the x to 1 less power. Make it pretty. Now, funny enough, Mr. AP, he doesn't like negative exponents, but he's okay with having radicals in the denominator. I don't know. Craziness. If I have a root like this, the root is the denominator, so this would be the same thing as x to the 3/7. 3/7 comes down in front, x to 1 less power, 7/7. If you take 3 minus 7/7, you get negative 4/7. Could look like this. You could also leave that if you wanted to. You could also say that this is 3 over 7x to the 4/7. Either way is fine. Whatever makes you happy. All right. A couple more examples, and then we will from the video, and then we'll get into our own examples. Number 7. Sometimes you need to remember the rules for exponents. When you are dividing like bases, you subtract the exponents. When you're multiplying like bases, you add the exponents. And so these two examples, 7 and 8, are going to talk about that. So if I have x to the 1st over x to the 1/2, 1 minus 1/2 is 1/2. This simplifies to x to the 1/2. Apply the power rule, 1/2 x to the negative 1/2, and make it pretty. And then they want you to evaluate it when x is 7. Okay, so put a 7 in for the x. There's nothing you can do with it. It's not like it's the square root of 9 or something that you could actually square out. So square root, so that you're going to end up just with an answer like that, 1 over 2 squared to 7. Number 8, you are taking x to the 1/3 is the same thing as the cube root of x. When you times it by 3, you're adding the exponents. 3 plus 1/3 is 3 1/3, 10/3. Find the derivative, 10/3 drops down in front. Subtract away 1, 3/3, you get 7/3. Plug in an 8. Now watch this, I'm going to talk about it. This is telling you that you need to cube root the 8. Well, that's 2. And then take 2 and raise it to the 7th power. That's 128. So you have 10/3 times 128. That gives you 1280 over 3. And there's your answer for number 8. Number 9. Here comes some AP kind of wording. It says, let f of x be x to the 4th and g of x be x cubed. At what values of x do the graphs of f and g have parallel tangent lines? Well, parallel tangent lines means that they have the same slope. Parallel, same slope, just like it was back in geometry. If I take the derivative of f, I get 4x to the 3rd. If I take the derivative of g, I get 3x squared. I want to know where they're equal, where those slopes are equal to one another. And so that brings me to the work right here. If I take these guys, set them equal to one another, solve it for x, factor out an x squared, you get x is 0 and x is 3/4. They are the values of x where these graphs would have parallel tangent lines, where they would have the same slopes. All right, so they're the lesson video notes, and we are going to go to some practice problems, starting with number 3. Number 3, pi to the x. They're asking me find the derivative. Again, the notation can be dy over dx. It can be y prime, however you want to write it, whatever you're happiest with. So I'm going to do y primes. They're just quick and easy. X to the pi. Pi comes down in front, and I have to take x to 1 less power. Well, that's really strange, but here's what it looks like. It's just pi minus 1. That's it. You can't say more than that. So it's the power comes down in front, take it to 1 less of that power. And there you did. You did it. Not a lot of work to that. Number 9, now these are like the examples like 7 and 8 were from up above. Number 9, you've got to play around with this first using what you know about rules for exponents. This would be like x to the 1st over x to the 1/3 cube root. I'm dividing like bases, so I subtract the exponents. Now notice I haven't even gotten to the derivative yet. I'm just working with playing around with this thing to put it up so I can get the derivative. 1 minus 1/3 gives me 2/3. Now I'm ready to derivative. Power comes down in front. X goes to 1 less power. 2/3 minus 1 will be 2/3 minus 3/3, or a negative 1/3. Make it pretty. If it's a negative exponent, it goes to the denominator. I have a fraction with a 2 up top, a 3 on the bottom, and I have an x to the 1/3. You could also write that as the cube root of x if you'd prefer. Either way is fine. Now number 10. With number 10, you've got x squared, and it's being multiplied by an x to the 5/6. The root is the denominator. And so what I need to do, if I'm multiplying like bases, is add the exponents. So when I add the exponents on this guy, I get 2 and 5/6. Well, that's kind of weird. We don't usually use a mixed number like that. We usually use an improper fraction. So I'm going to write it one more time. And you can even think if you're going to do a power rule on that, that would be kind of ugly out in front. So 2 times 6 is 12. 12 plus 5 is 17. 17/6. There we go. That's the form that I want, so that I can now take the derivative. The derivative is 17/6 x to 1 less power. Well, 1 in 6 terms is 6/6. 17 minus 6 is 11, so I get 11/6. There's my derivative. The next set, they change up the directions, and they want to know what's the value, what is f prime of some number, and they're going to give me what the number is for each of these, given the value for what a is. Well, if I want to find the derivative, again, I need to set it up so it's a power so I can apply the power rule. This guy is a cube root of x in the denominator. In other words, it's x to the negative 1/3. All right, so find the derivative first. F prime of x. Power comes down in front, negative 1/3. X goes to 1 less power. If I'm 1/3 and I subtract 1 away, 3/3, 1/3 minus 3/3 is a negative 4/3. Well, again, I need to make it pretty before I do anything else because we don't like negative exponents. I get negative 1 over 3x to the 4/3. But now I need to plug a 27 in, so let's see how that works. F prime of x equals negative 1 over 3 times 27 to the 4/3, and I got to figure out what that's going to be. So let me math with you a little bit here. All right, 27. I need to cube root it from the denominator here. The cube root of 27 is 3. And then I need to take 3 to the 4th power and figure out what that is. But really I have another 3 here, so it's really 3 to the 5th power. So if I go negative 1 and I take, this becomes 3 to the 4th. This is a 3. 3 times 3 to the 4th gives me 3 to the 5th. And that is 243. And there's your final answer for that. So they'll just find the derivative and plug it in. Plug in the number. All right, next kind, 17. 17 is next on my list. Let me find it here so you can see it. 17, I have 1 over x to the 4th. Well, that's the same thing. Again, I'm playing with the function before I derivative. X to the negative 4. I'm going to figure out what that is. Now, what they want me to do this time is find the equation of the tangent line. Well, anytime you need an equation of a tangent line, you need 2 things. Any line, you need 2 things. You need a slope. In our case, that's our f prime of x. And we need a point. Some point that is xy. All right, the doggy's going crazy. All right, so I'm going to take the derivative, f prime of x, bring down the negative 4, power comes down, bring it to 1 less power, make it pretty. Make it 4 over x to the 5th. What's x? I can actually figure out the actual number for what the slope is because they told me that my x was 2. So I have negative 1, or negative 4, over 2 to the 5th. Plug it in. Or negative 4 over 2 to the 5th is 32. And 4 goes into both of those. I get negative 1/8. There's my slope. But I also need a point. So here's my slope. My point is 2 xy, right? 2 something. How do you get the y? You go back to the original equation. You plug it in. 1 over 2 to the 4th. Well, 2 to the 4th is 2 times 2 times 2 times 2. It's 16. 1/16. Now you have the pieces. You have a slope and you have a point. You can put it in your formula. Y minus y1 equals m times x minus x1. There's the equation for the tangent line at the point x equals 2. All right. Changing it up one more time. We have 18. When do the two functions listed have parallel tangent lines? Well, you saw that in one of the examples, that you need to figure out the slopes, and the slopes have to be equal to be parallel. So I want to know what's f prime of x, and I want to know what's g prime of x, and I'm going to check those out. I got a 2x here. I have a 5x to the 4th here. Power rule, gotta love it. And I'm going to set them equal to one another. 2x equals, has the same slope as 5x to the 4th, and then you solve it. So that means that you're going to move the, well, however you want to move it. I'm going to move the 2x to the right. 5x to the 4th minus 2x is 0. Factor out an x. 5x cubed minus 2 equals 0. Set my things equal to 0. The x I factored out, my grouping of 5x cubed minus 2. Swing the 2 to the right. 5x cubed is 2. Divide by 5. I'm going to come over here. X cubed is 2/5. And so then it's just like if you were having a square root. If it were x squared, you were bring square rooty out. This time you've got x cubed. You're going to be cube rooting this whole thing. Cube root that side, cube root that side. That's the only way you're going to get out the x. So x equals the cube root of 2/5. And then the discussion is it plus or minus? You know, when you take a square root, otherwise it's plus or minus. Does that work with a cube root? And the answer is no, it's an odd root. You don't need to worry about that. Because if I take with odd things, if I take and cube them, they have the same sign as what they originally had. So it's not like the plus or minus that you can use with square roots or even roots. So there you go. That is number 18. Number 19, why would I do both of these questions? Because number 19 is entirely different. So here we go. Same process, just the answer's a little different. All right, so I can't take the power rule to a square root looking like that, but if I change it, it changes to x to the 1/2. My g of x is fine the way it is, x cubed. Derivative it, 1/2 x to the negative 1/2. G prime of x is at 3x squared. If I pretty this up, I get 1 over 2x to the 1/2. And my deal is I need to set them equal to one another. And you're going to say, what? How am I supposed to do that? And you're lucky to hear you can use a calculator. All right, so let me grab my calculator. There are a couple different ways that you can do this. You can put it in your solve, in your algebra part of in the home menu, or you can go to, well, the way we're going to do it is the way that they kind of show it in the video that he did, and that is to find a point of intersection. So let me go with that. Here's my two functions. I'm going to put y1, I'm going to put one of the functions. And I like your calculator because it literally types it in after, well, it shows you what it looks like so you can compare it to what it should look like and make sure that you're talking the same language. So I'm doing 1 divided by parentheses 2x to the 1/2, so I'm going to make it 0.5 and close my parentheses. Make sure it looks right. Yep, I got 1 over 2x to the 0.5. And the second one I've got 3x squared. That one's easy peasy. Alright, so there they are. I'm going to graph them. Busy. There's one, there's the other. Alright, so I can see that they intersect each other kind of right about here, somewhere between 0 and 1, according to my tick marks on my axis there. So, to find a point of intersection, go F5, go down to number 5, and it blinks the blink and blinker on one of the curves. And you can see it's curve number 1, it's in your Y1, so you're good, that's 1. And then you want it to blink on the other curve, well, it goes to 2, so you're good, that's good. It automatically put it on both places. Your lower bound and upper bound are your left point and right point. So you got to go left of where you think it intersects, and you got to go right of where you think it intersects. Well, left of where it intersects, we said it intersects somewhere between 0 and 1. So your lower bound is 0, your upper bound is 1, and then you say, okay, tell me what it is. Busy? Really busy. There it is, 0.488. That is my x value. X equals 0.488. That's the value where they would have the same slopes. So you're using the calculator to help you with that one. All right, number 23 is going to finish us up. Number 23, because this one is quite the doozy. This is, again, typical AP kind of question. Let me see how much of this I can get on the screen. 23. Good enough. All right, in the figure to the right, line L is tangent to the graph at y equals x cubed at a point A with the coordinates a, comma, a cubed. Line L crosses the x-axis at point B with the coordinates b0. Find B in terms of A. And you look at that and you go, what on earth are they asking me to do? I have no idea. All right, so let's start with the thought of a tangent line, right? This is a tangent line right here. You've got 2 points. And you can, if you figure out what the slope is between those 2 points, you can actually figure out what your A and B values would be. So we're thinking about the equation of the tangent line. Well, in order to find the equation of a tangent line, I need a slope. In other words, I need what y prime would be. Well, y prime is, here's my x cubed, is 3x squared. And what is my x value? My x value is a. So in other words, this would be equivalent to 3a squared. I have, that's my slope. I'll keep using arrows. My slope. And I have a point on my tangent line, and the point is a cubed. All right, so we have the ability to put that together into a point slope formula. Here's what it looks like. Y minus y1, a cubed, equals m, 3a squared, minus x1, x, where's my x? Y minus y1 equals 3a squared, x minus a, my x value here. All right, well, we're close. Because the other thing I can actually figure out what x and y are, because they told me I've got a point, an x-intercept that is b0. So if I replace my x with a b and my y with a 0 in this equation, I might be on the road to figuring out what my a and b would be. Let's try it. If y is 0, negative a cubed equals 3a squared, and x is b, but b minus a. Here's what it looks like now. Let's see if we can clean this up and solve for b. Find b in terms of a. So I've got negative a cubed equals 3a squared b minus 3a cubed, right? 3a squared times a. Just distributed the 3a squared out, that whole thing. And interestingly enough, you've got like terms. So this negative 3a cubed can come over here and join up with the negative a cubed. This guy becomes positive, so really you end up with 2a cubes equals 3a squared b's. And you want to solve for b, get the b by itself. So you're going to divide out the 3a squared. That's going to give you this, 2a cubed over 3a squared equals b. And then you're going to divide out the a's, simplify them, so you have 2a over 3. Have you solved for b in terms of a? And you have. Here it is. b equals 2a over 3. And then the rest of this is way easy peasy, because now it says, well, what's b if a is 9? And you're like, that's no big deal to me. If 2 times 9 over 3 tells me what b is, that's 18 over 3, or 6, and you are done that number 23. Which seemed really crazy hard, but once you see it, it's not that bad. All right, so that's section 2.5. If you have questions or issues, shoot me an email. Have a good day. Bye.